So in previous classes, what you would have studied about congruency of triangles in class 9. In class 10th, you will be studying about the similarity of triangles, right? So probably you might be knowing about the difference between the congruency and similarity, right? Congruence means same shape and size are also same. So if both are same, then only we can say those two figures are congruent. But similarity means it is enough if, so under this triangles, we will be studying about similarities. So similarities means you should have same shape, but the size may or may not be the same. It is not necessarily to be the same, but the size should be in proportion. The sizes should be in proportion. Need not to be same. So that is the thing in the similarities of triangles, right? Okay. So based on this property, we have a basic proportionality theorem. Basic proportionality theorem. In simple, we call it as BPT. Right. So what this theorem suggests, let us consider a triangle ABC. Right. And I'm going to draw a line parallel to BC. Let me name that parallel line as D. Okay. So the BPT says that if a line is parallel to any one of the sides of the triangle, then this parallel line would divide the triangle in proportions. That is AB is AD by DB is equal to AE by EC. Right? So their sides are in proportion. If a parallel line is present, which is parallel to any one of the sides of the triangle. So this is the BPT theorem. So this is the basic for about this triangles. So we will solve the problems. You will get more clarity. So let me clear the board. Let us go to the problem directly. Okay. So what it's given, we need to write symbolically in which triangle ABC and DEF are similar. We need to find the similarity of triangles, right? So how you can prove the similarity of triangles? Either you can prove the similarities can be proved by either AA or AAA or triple S or SAS. So using any of these three categories, you can prove any triangles to be similar. How? Those corresponding angles should be equal. Only if two angles are equal, obviously the third angle would be equal according to the angle sum property of triangle. So it is enough if you check only the two angles, corresponding angles of the triangles. So if two corresponding angles of the triangles are equal, then those triangles are similar. Next, if all the corresponding sides of the triangles are equal, then those triangles are similar. Next, if actually all the sides are in proportion, not equal, proportion. Angle should be equal. Angle should be equal, but the sides should be in proportion. And in SAS, if the two sides and the included angle should be equal and the two sides should be in proportion with that of the other triangle, then you can tell those triangles are similar. So you can use these three categories to prove any triangles to be similar. Okay. So now look at these two triangles, what it is given. See here, by looking into the triangle itself, you know this is 10, 20. So double of this 10 here is 20. So double of this 12 is here 24, but it is in some rotated form. We need to correct it because the corresponding side should be in proportion. That is very important. So we need to slightly rotate this second triangle. So keep the first triangle as such. Second triangle, D is the common part, E, then F. So DE is, okay, DF, it should be DF. DF is 12. DE is 24. Then this is 30. Now see, all are in proportion. AB by DF is equal to BC by DE. So 10 by 12 is equal to 20 by 24. Right. So which triangles are similar? ABC and FDE. So which one? This one. ABC and FDE. Option C matches our answer. Correct? Is it clear? It's very easy. Just a simple rotation, then fixing the corresponding sides, then writing the triangle name in correct order. Writing the triangle name in correct order is very important in similarities. Okay. So, shall we move on to the next problem? Yes. Let me clear this. We'll go to the second problem. Okay. So look at this problem. So two triangles are given, and in the question itself they have given they are similar. So easy peasy this sum. So find the length of, they're asking to find the length of PQ. So we know that if two triangles are similar, their corresponding sides are in proportion. So using that property, we can find the unknown side. So first let us rotate this triangle in the correct order so that their corresponding sides matches. So draw the triangle. So it is P R Q. RQ is 4 centimeter. We need to find the PQ. Okay. So always match with the known side with the unknown side. So we need this side, right? Both the sides are known. So you take the proportion of these two sides, right? So now, how to write it? See, we know these two sides. So we will take these two sides. Only then we can find the unknown PQ. So these two sides, what is that? AC by AB. AC by BC, sorry, BC. AC by BC is equal to the corresponding sides you need to write. That is very important. PQ by RQ. PQ by RQ. Then just mere substitution to find the PQ. Let's substitute it. What is AC? It is 3. What is BC? It is 6. And we need PQ. What is RQ? It is 4. So PQ is 12 by 6, which is nothing but 2 centimeter. So the answer is option B. Right? It's very easy using the similarity of triangles. So in the sum, what you are going to do? What is the property of the similar triangles? Their corresponding sides are in proportion. Using that property, we wrote their sides in proportion. We substituted the unknown known sides. Then we found the unknown side. It's very simple, not a complicated one. Shall we move to the next sum? Okay. Okay. So we'll move on to the next question. So what it is given, so there are two parallel lines. Simply I will explain this. So it is given that there are two parallel lines which is parallel to the side BC. And they have given the PD value. So PD value they have given. What is PD? It is 3.1 centimeter. And we need to find the BC. Right. Okay. Now we will solve this. See, and from BPT, we know that if a parallel line is drawn to any of the sides of the triangle, then the parallel line would divide the sides in proportion. So we know that property. So using that property, we can write the sides in proportion. Using that proportion, we can find the unknown side using the given side. Okay. Now see, there are two parallel lines parallel to the BC. See, look carefully. I'll let me show you in a different color so that you can view it clearly. See, this is a triangle, a smaller triangle, and another one is this triangle, a bigger triangle. Right, we are going to compare this small triangle and the bigger triangle, and one more triangle is also there, the medium triangle. So we will leave that because only two to write the proportion, only we need two triangles, and our unknown is in the bigger triangle side. So it is enough you consider those two triangles. So what we need? Only two triangles. Okay. So now how you can proceed? So we know these two triangles. So one smaller triangle and one bigger triangle has formed because of the parallel lines drawn. Right. And see here, since two parallel lines are drawn, the triangles have been divided in proportions like here. Meaning the bigger triangle has three parts. The smaller triangle has one part. And the medium triangle has two parts. Using that logic, we can write the proportion because they didn't give any of the length of the sides. So we need to think logically to write in a meaningful way. So consider triangle APD and triangle ABC. So smaller triangle and larger triangle. Using these triangles, we are going to write their corresponding parts. So by BPT, we can write AP by AB is equal to AD by AC. So AP is the side of the smaller triangle, AB is the side of the bigger triangle. Then again AD is the side of the smaller triangle and AC is the side of the bigger triangle. So we have written the proportion like smaller by bigger. Side of the smaller triangle corresponding to the side of the bigger triangle. Okay. So now we know that these are in the okay, actually we need the unknown side is BC, right? So we will write so one side is AP by AB, then PD by BC. This side we are considering. This side and this side, these two sides. Writing the proportions. Okay. And we know the proportion, what are the smaller and the bigger triangles are in the proportion of 1:3. Right. By looking into the triangle itself, we can easily visualize it. So, and we also know the PD value, just substitute it. PD is 3.1 and we need to calculate the BC. Then we know it is in the proportion of 1/3. Now, BC is nothing but 3 into 3.1. That's it. 9.3 centimeter it is. Got it? It's so simple, right? So if two parallel lines are given, then you can consider the smaller triangle and bigger triangle proportion and write the known side. The known side is this horizontal line. That is, we need this horizontal line side. So we have taken the ratios of the horizontal line, and one more side we have taken, any side you can take, because the smaller and bigger triangles are in the ratio of 1:3. Either you can write AP by PB or AP by AB or AD by AC. Anything you can write. Got it? So this 1/3 is very important. Please remember that. So the triangles are in the ratio of 1:3. The smaller and the bigger triangles. Right? Okay. Shall we move to the next problem? Okay. Now they have given in the question itself, they have given, see, both the triangles are similar. So it's very easy, right? So when we see the similarity symbol in the question, it makes us very happy because our job becomes very easy. Okay. Because we can use the property of the similar triangles, that their sides can be written in proportions. Okay. So we need to find the angle C. It's so easy. Listen. See, what they have given, ABC is similar to AED. ABC is similar to AED. So here, ABC is similar to AED. So the angle A is 80 and the angle D is 70. And we need the angle C. So for better understanding, I have drawn these two smaller and bigger triangles separately. Right, so that you can view the corresponding sides easily, corresponding sides or corresponding angles easily. So listen, it is given that we need to find the angle C, right? So angle C corresponding angle is angle D, not angle E, right? You should see the similarity symbol, similarity name. According to that, you need to match it. So angle C is, since both the triangles are similar, we can tell that angle C is equal to angle D. So angle C is equal to angle D by BPT. Then therefore angle C is nothing but 70 degree. It's so easy. See, very simple, right? But be careful, angle C is not equal to 70. Angle C is not equal to this angle E, right? So what they will do, they will be finding the angle E value by angle sum property. It's wrong, because angle C corresponding side angle is angle D, not E. That you should keep it in mind, right? Okay, is it clear? So we move to the next problem. Okay. Okay. So this is also another ECPC problem. Okay. What it is given? It is given perimeters of two triangles are given. Okay. So their perimeters ratios are 40 is to the perimeter ratio of the two triangles. It is given 40 is to 60. So it becomes, when you simplify this, it becomes 2 is to 3. So 2 is to 3 is the, and we know that if two triangles are similar, then not only its sides are in proportion, not only, it is a very important point, not only its sides are in proportion. What are the other things which are in proportion in the similar triangles? Not only sides, their altitude, then their perimeter too, all are in proportion, all are equal, all are in equal proportion, all are in equal proportion. Equal proportion. So the perimeter ratio is also equal to its sides ratio. So therefore you can write their sides ratio as same as that of the perimeter ratio. It's very easy. And what's the formula for what's the relation between the area of the triangle and the side of the triangle? It is the area ratio is equal to the ratio of their areas is equal to the square of their corresponding sides. Square of their corresponding sides, not just simply the ratio of their sides, but square of the ratio of their sides. It is very important, not the simple side by side. It is side square by side square. So you need to square it, that's it. So we need the ratio of the triangle, two triangles given. So we know the proportions of their sides. Just if you square it, you will get the ratio of the area. So it is 2 square by 3 square. So the ratio is 4:9. Right. So the answer is 4:9, option B. Is it clear, everyone? Okay. So the remaining problems we'll do it next class. Thank you.